Hi, this is Dr. Gulshan S, your physics and math tutor. This question is on a free body diagram and is a long question. You have a 25 kilogram block, which is block A, on a frictionless table, and it's a cord connected to it, and there's another mass of 7 kilogram hanging on the other side. And then if the block A travels 0.5 meters, what's the velocity at that location? So if you take the free body diagram of mass A, it has a 25 kg mass. So a force of gravity of 25 g is acting down and normal reaction is acting up, and therefore these two forces balance each other. The only unbalanced force here is the force of tension, and then that provides an acceleration to this body, and therefore tension equals 25 times A, that is mass into acceleration. That is equation 1. Likewise, if you draw the free body diagram of mass B, it has 7 kilograms of mass, so 7g is acting downwards, tension T is acting upwards, and this tension is same as here because it's a single cord, and therefore equation becomes 7g minus tension is the net downward force, that is mass into acceleration. So this is equation 1, this is equation 2. If you solve these two equations for acceleration, then that acceleration works out to be 7g divided by 32, and that is 2.14 meter per second square. So this is the acceleration of both the masses. The mass A is moving to the right, and mass B is moving downwards. Now, if you want to calculate the final velocity of A after traveling a distance of 0.5 meters, 0.5 meters, then you have final velocity of A equals twice of A times distance moved. So if I plug in the value of distance as 0.5 and acceleration as 2.14, I get the velocity final of A after traveling a distance of 0.5 meters is 1.46 meter per second. Likewise, this is another mass which is also going down in the acceleration, same as 2.14 meter per second, and it travels a distance of say how much distance the other one travels. It travels a distance of 1.2 meters before touching the ground. So if I use the distance to be 1.2 meters and then find out the value of time it takes to touch the ground, then you use the formula, that is distance equals to 2a tb square, because the initial velocity of B was also 0. So this time for which it travels before touching the ground will be 1.06 seconds. So now this mass has touched the ground, and once the mass B touches the ground, this string does not have any more tension, and therefore this mass A keeps on traveling further distance beyond 0.5 meters, and it keeps moving the same acceleration, and once it reaches the pulley, if it gets stuck to the pulley is okay, but if it goes beyond, then it will fall with that horizontal velocity and will touch the ground finally. So the part C is what happens to block A once block B touches the ground. If it is stuck by the pulley is one thing, or if it keeps moving, it will take a trajectory and finally touch the ground immediately once the mass B has gone to the ground. So I hope this makes everything clear. There's a simple application of free body diagram. Thank you.